This Late Night Linux Family podcast is made possible by our patrons. Go to latenightlinux.com/support for details of how you can join them. Support us on Patreon for access to ad-free episodes and early releases. That's latenightlinux.com/support. Hello and welcome to episode 142 of Linux Dev Time. I'm Joe.
I'm Amalith.
I'm Kevin.
And I'm Andy.
Good to talk to you all again. Kevin, something you've been thinking about lately is complexity in software. And you brought up the example of people who like to brag about how their project's only 500 lines of C.
Yeah, so complexity in software is one of those things that it's difficult to judge from the outside and therefore leads itself to like a lot of these really weird like fixations. And combine into that also that we've had, software seemingly get slower over the years, right? Where people notice like, loading bars and all these kinds of things that make software just seem a lot slower and more bloated than it was before. So all of this stuff kind of mixes together into what I would call like software complexity. And one of the ones that just personally kind of gets to me is when there is like some bragging rights on what I would say are like arbitrary numbers, like, oh, I did this in only 500 lines of C, or I made an entire Docker rewrite and I only used 400 lines of bash. Just silly stuff like that gets a lot of praise and meaningless internet points. But it's interesting the fact that like usually you can achieve those kinds of like wild numbers by also cutting like all of the functionality. So like nothing's for free. And it's just kind of funny that a lot of software engineers kind of fixate and like hyper focus on these types of like strange messages around like complexity.
This reminds me of a thing that Joel Spolsky talked about a bit, which is there was this saying that most people only use 10% of a piece of software. And he was talking about like Microsoft Word, Microsoft Excel, stuff like that, and saying, well, yeah, most people use the kind of core functionality of the software and then maybe one or two obscure little bits. But everyone uses different obscure little bits, and it's absolutely critical to them that they have that obscure little bit.
Yeah, and that's something that's hit me directly, or at least it's been a frustration of mine before when working on open source, is I would see people having different bug reports or feature requests for all these various different things, and it kind of accumulates to the total piece of software. And then other people will come out and be like, hey, I rewrote this software in a different package, much smaller, much faster, all these other things, but it only does like one thing that this does as well. And to me, like that's a silly trade-off to make. Like you're making software that doesn't do as much for your users because you think that it was smaller and quote unquote like more simple. But exactly like you said, if there's a bunch of different people, they all use like different slices of the software, and it's really hard to make like all of those pieces perform well, be well tested, all that sort of stuff. So it's just a personal frustration that I've run into over the years.
I do see some articles complaining about the size and complexity of particular pieces of software. One example fairly recently was Gin, the web framework for Go. And one of the big complaints about it was that, first of all, it's very old. It's based on a different library from early on in Go, where the standard library didn't have as many nice convenience functions. So lots of the architecture in Gin is present and difficult to re-architect around because it was written so long ago. That's one of the complaints. Another one is it doesn't actually model the problem space very well. Trying to interact with HTTP via Gin requires all this crazy API use because Gin's API is so sprawling compared to the standard library's net HTTP that does model the problem space very well. The API you interact with net HTTP is very close to what you would expect learning about just HTTP itself, raw HTTP, while Gin deviates significantly from the primitives you learn as you learn about raw HTTP.
I think it's that sometimes you don't know which it is from the outside. And very often in software engineering, people assume that it's either accidental complexity or unnecessary complexity, when either in fact, because there are like hidden complexities in there that have to be addressed, or just from the outside, like you just don't know. And so it just seems unnecessary to you. That seems to be extremely common in software engineering.
Absolutely, yeah. Like so the whole rewrite from scratch thing that we've been over and over is because you take a look at a bit of code and you think it just can't be this complicated. It's only doing a simple thing. And then you see some bits of code that are like, well, that's way more complicated than it needs to be for that thing. And what you're missing is all the bits of code that are messy and difficult because it actually is needed if you're actually going to fix the problem properly. So your best bet is to take the old code, fix it so that it's no longer messy and it's still got all of the complexity that it needs.
But then I also wonder why a lot of software engineers will, like I said, overfixate on a particular metric, like lines of code. I've also seen this in reviews that people will do, and they'll be like, hey, this could have been done in fewer lines of code, like code golfing something down to fewer lines of code, or this is a good implementation, like assigning quality to lines of code, which to me also, like, those are completely different metrics. The quality of code and the lines of code, while they might be loosely connected in some cases, they don't directly point one to the other.
Yeah, you've got to apply a lot more good taste than just getting the number of lines of code down. Otherwise, you can do awful things, can't you?
But then I also think it might have to do with probably just human speech, and that we don't very well articulate all of the features of something. And so we look at something like curl, and we're like, how hard could it be to do an HTTP GET request? Like, come on now. And meanwhile, like, curl is probably one of the more complex pieces of software. Now, it supports all kinds of protocols, and it does way more than just HTTP GET. But from the outside, especially if I only need an HTTP GET, maybe that is a reason that I'm looking at that. But it also might just be that, like, I don't know. And it's so easy to, like, hyperfixate on only these few little features that you know about and or need. And that's just another thing that even in junior software engineering, I've seen it become either dismissive or sort of like discouraging to more junior developers because it's just so prevalent in software engineering.
I think curl is a really good example of a phenomenon you can also see, which is that someone who's used to using an HTTP library and a library with a really good interface, so it feels really simple and straightforward to them, assumes that the person who implemented that library has written really simple and straightforward code, when actually there's probably all kinds of mess inside there that's needed. And then they've just presented a really good interface to you. So you think using HTTP is simple. And that's why you think curl is simple.
There's also exposing the complexity to the user. And this is a little bit different in like a library versus a tool or an application. But for example, like Rust is really good about exposing, I would say, necessary complexity. But things like the string type, like what is a string, right? It's bytes in a row. But Rust says like, oh, there's actually 16 different string types, and they all have different pros and cons and different usages because it doesn't try to hide some of the complexity that is there when handling strings of characters. So that's one where as a library author, or even not really so much an application author, but as a library author, you could say like, do I expose this complexity to my users? And you might think it's necessary complexity, where other people might look at it and be like, what is this sprawling API that this person has developed? So like knowing the audience of that, I think is also can be useful.
Yeah, and I think Rust strings are a great way to figure out who's going to like Rust and who's going to not like Rust, right? Because if you explain how the strings work and someone goes, oh, wow, yeah, I've had trouble before where the command line arguments were coming in the wrong encoding and everything went wrong and I didn't have a way of dealing with that. And actually Rust gives me the power to control that. Or someone goes, what? Isn't a string just like some characters? I mean, actually, I was looking with some colleagues today at the Gleam programming language, which is a syntax on top of the Erlang environment, the Beam environment. And their strings are implemented where the kind of main thing that you're dealing with is grapheme clusters, or graphemes, they call them. So that gives quite a human, understandable interface to a string to you, right? It's like, if it looks like a kind of a character to you, like an eacute or whatever, then it is a grapheme. But the trade-off there is for complexity in the standard library of that programming language, because in order to handle graphemes, you need megabytes of data about how the Unicode code points combine together into graphemes and stuff like that. So you've pushed the complexity into the standard library, which potentially then affects everyone who uses the standard library. And how do you feel about that?
I think that slightly touches on something I've been telling a lot of the people that I work with when they run into these types of things where they don't know if something is accidental complexity, necessary complexity, and are very quick to judge. Hey, this could have been done better. It could have been done like this. And something I've been encouraging people to do is consider the original constraints and requirements of whoever wrote that piece of software, whether it be a library or an application, or part of the standard library and how they were handling Unicode code points. But if you stop for a second and think about those types of things, it can be illuminating to be like, oh, hey, actually there were other things they were trying to consider or trying to worry about. And then you can also have a better discussion with yourself or with your team about like, do those same constraints and requirements still apply? Or do they apply to the thing that we're trying to do? Because the answer can be later on, no, they don't apply, and we can do something differently, or it could have been done better. That's the other part that's like really hard to mix in is while I try to be very slow to criticize, that doesn't mean all software is good, right? Or that all complexity is good. And that's something that I would say programmers struggle with in general, is kind of like the human nature of programming. And that's like talking, articulating, getting your points across, and saying that software could have been done better in a constructive manner is another difficult skill to get over or to learn.
I think we had a really good example of a trade-off that we had at a place I worked a few years ago, where the old system that everyone hated had this custom request handler. And part of that was some code that we didn't really understand that did some stuff with DNS that we didn't care about. So the rewrite just used the Java DNS HTTP libraries and it was fine. Then we had an outage, and it turned out that the old code could handle the situation we were in, which was when the DNS server wasn't working properly, and the new code could not. And we discovered why that complexity had been introduced into that code. But there's still a trade-off, right? Like, it might have been the right choice to accept that you have an outage when that happens.
I wonder if there's some sort of corollary between like where somebody is in their sort of programming career journey, or even if it's not a career, just if it's a hobby, but like where somebody is in their journey as to how often they will jump to thinking something is necessary complexity or not. And I'm trying to think back through just like my own life, right? And I would say it's an odd curve, because I would say it happens more on the very junior and very senior ends. Like in the middle is kind of where people are scared enough to say like, I don't know if that's necessary complexity or not, so we'll go with it.
I thought you were going to say the other way around. I thought you were going to say when you're a junior, you're scared of everything, so you don't want to criticize the code. And then when you're in the middle, you're like, oh, this is all rubbish, I'm going to rewrite it all. And then when you're a senior, you're like, oh, okay, there's probably a reason for this. And then you look into it and figure it out.
Maybe there is gradients. So maybe I'm thinking more on like the high end of junior and low end of senior. So I don't know.
There's like 7 different levels.
Exactly.
I think I skipped that first stage of thinking everything is rubbish when you're a junior. I accepted everything as it was and was like, okay, this is probably fine. This is probably all here for a reason.
People that have joined my teams in, previous jobs, or sometimes even open source, but like if they join directly out of college or university, like sometimes people are just really quick to jump in and be like, oh, there's a better way to do this now, and like hop in and do some things. So I think maybe more like production or in a work setting is where you'd be a little bit more hesitant to just like make wild changes, because the company's money rides on that, as does your employment.
I must have told you about how 2 weeks into my first ever job, I was sitting at my computer with my boss saying, I cannot understand why anyone would have written it like this. Why have all these methods all got the same name? And he was like, kind of sheepishly said, yeah, it was quite late at night. And I was like, no.
Always check the get blame. That's what you should do before you make any comments, positive or negative.
It was devastating, but it's a great example of you think you know it all and you're not thinking about the constraints that were in place at the time something was written.
But even just that constraint of like, oh, it was late at night, I didn't have coffee or I was tired. Like that can apply to really any scenario, even if you are fully caffeinated in the middle of work. Like people can have stuff going on in their personal lives that keeps them distracted. So that's why I'm also like hesitant to say like all software is good software. Like that's definitely not true.
All software was written by a human.
Thankfully for now.
Increasingly not so, though.
No, a human still had to say, do this.
And take responsibility for it.
Or had to accept the output.
Yeah.
Yeah, so I think maybe a good approach is all software does something useful. Almost all software does something useful and has value. And all software can be improved. And so the state we find it in right now is not like this permanent thing, and it's not a disaster. It's just, if you can see an opportunity to improve it, then that's probably a good thing to do.
I think personally, I would just like to see fewer of the clickbaity, I re-implemented Docker in 20 lines of bash, and have a little bit more nuanced discussion about it. I re-implemented a very small subsection of Docker in bash just for fun because I could, and I got it. That's less clickbait. You're going to get less clicks, but I think it would be a healthier environment for all software engineers, because you have software engineers of all levels reading these things and understanding like the nuance behind software and complexity.
Yeah, whereas an interesting conversation you can have around a project like that, like definitely, by the way, do projects like that, like try and re-implement something in 500 lines of bash, that would be great. And the interesting conversation to have about that is, what are the facilities that we have now that we didn't have when the original was written? Or what are the shortcuts that you're taking or the features that are missing that make this simple? And is there something you can learn about the real thing from doing this simple thing? Like, is there something essential about it that you have captured in that simpler version that helps you understand the real thing or something like that?
Yeah, exactly. To be clear, like I'm not against these types of articles or projects. I think they're amazing. And I think it's really cool to watch when someone's like, I could fit all of Windows XP into 500 bytes of RAM, right? Or just something insane like that, right? And it's really interesting to see how like the links that people will go to and the tools and techniques that they will apply in order to hit these arbitrary constraints. That part is awesome. That's really cool. But that's also more of like a learning, teaching, exploration type project, and less advertised as the I made something better, and here better just means more simple, fewer features, less complex, which those are all elements of good software, but they are not themselves qualitative of good software.
What about software that is made up of modular chunks, for want of a better word, like the Unix philosophy, chaining smaller, simpler pieces together to make something that is ultimately more complex?
That can bring its own complexity in that how the hell do all these little pieces fit together? This thing can't communicate with this other thing because it goes through two other things on the way, and something in there is broken, and now you have to read through and understand these 4 different components and fit all of their interactions and nuances in your head at once to understand what could be going wrong in the chain.
And also those individual components will often grow themselves. They'll get more features, and eventually like knowing how to glue all that stuff together, whether it be like a bunch of different command line utilities or whatever, is its own task and like daunting skill. So I think it's weird. Programmers do like to break things down into smaller bits. And I think that maybe that's how we got about with like microservices and things. But there is very much a difficulty when you break things down too much to now you just have like a box full of tools, and it's difficult to assemble them into the thing that you want at the end.
Yeah, like I'm a massive advocate of the Unix philosophy and generally of breaking things into small bits that you can fit together. But there are 2 key points about that. Number one, all programming is that really. Like when you write a function or something like that, that is like a small tool that you're going to use as part of your larger program. And the key thing about that is you need to build the right tools. Like if you want to make your big program make sense and be simple and reliable, that's going to happen if you've built tools that fit the jobs that you're doing and make it look simple. And the other aspect of that is inside those tools, there might be quite a lot of complexity. And the trick is to make it look simple from the outside, like we were saying about curl or HTTP. Make it look simple, even though inside you're dealing with a whole load of complexity. That's why that strategy is cool, because suddenly the people using your stuff from the outside don't have to think about all that complexity that you've hidden away inside.
But doesn't it follow logically that the more complex your software is, the harder it is to test? And I know that you are obsessed with testing, Andy.
Well, the point is, if you make tools that really nicely fit your problem, and often people will talk about that as if you're actually making like a programming language, like you're building a language which you can use to talk about your problem, then that has 2 aspects to it. Number one, the higher level program where you're speaking in that language is easy to understand and hopefully even easy to test, but certainly easy to understand and easier to get it right. But also, if your tools, the building blocks that you're building are independent enough, then you can test them separately. And where this becomes difficult is, it's all very well knowing that your tool does what it's supposed to do, but does combining it together in that way make it work the way you really need it to do in the wider problem? But if your tools are simple to understand, like it's a hammer, it just hammers nails, then it's easy to check that your hammer does hammer nails. If a hammer is what you needed, then you can then use it in your furniture building job without worrying about whether it works because it's well tested.
But the hard part about that too is like whatever you expose to the public. So, you got your hammer, which exposes out the, the flathead and the claw on the, on the other side. whatever you expose to the public, like that is an option for a permutation combined with something else. So any other things that have a bunch of extra options, like you can end up with all these various permutations that are technically valid. Like you could hit a screw with a hammer. It's technically valid, like you can do it, but it's not the intended way to be used. So creating a monolithic screwdriver that goes all in one, like that would be one way to like kind of avoid that. Now, I'm not saying advocating for that type of software engineering, but just the more things you expose in your individual tools, the more permutations you have to use it with other types of tools that are also meant to be used with it. So I like to think back to Gall's law on these types of discussions, which says something along the lines of, I don't have it pulled up, so I can't read the direct quote, but something along the lines of like any complex system that works invariably came from a simple system that worked. So like you're not going to design a complex system up front, even like no matter how modular or, you know, in whatever kind of like microservices you want to design it. You have to start with what is the problem I'm trying to solve and solving that. And then it sometimes organically grows into something more complex.
100%. And you don't know whether you understand the problem at all if you don't have a program that actually does a thing, even if it's not the whole thing yet. But now I'm just imagining capitalism taking us to the point where all screws are sold with an integrated screwdriver.
Single use.
Either that or the threads fold away and turn themselves into a nail. I don't know.
So some people say that programming is managing complexity. That is what the job is. And I think I probably agree with that. And I would also say that the way you manage complexity is by breaking things into things with simple interfaces that hide their complexity from each other. So maybe when we're talking about complexity, we're really just talking about programming.
And I would add to that, next time you're looking at something that's complex, could be broken down smaller, just ask yourself why something was done a particular way. And if you know all of the parts, to truly say whether or not something is overly complex or could be done, quote unquote, less complex.
Right, well, on that philosophical note, we should probably get out of here then. We'll be back in a couple of weeks, but until then, I've been Joe.
I've been Amalith.
I've been Kevin.
And I've been Andy.
See you later.